Hello, curious minds. Welcome to Paper Ledge, where we transform cutting-edge research into captivating stories. Today, we're diving into a fascinating paper about tool retrieval for large language models, or LLMs. Now, imagine you're in LLM, a vast digital brain capable of incredible feats, but you're also facing a challenge. You have access to a gigantic toolbox filled with specialized instruments. We're talking thousands of tools. But your workspace, your context window, is limited. How do you choose the right tool for the job without getting lost in the clutter? That's exactly the problem this paper tackles. This paper, cleverly titled ToolDreamer, Instilling LLM Reasoning into Tool Retrievers, introduces a novel framework to help LLMs navigate this complex landscape. The authors, Saptarshi Sengupta and team, at Penn State and Bosch Research North America, realized that simply matching keywords between a user's query and a tool's description isn't enough. It's like trying to assemble a rocket ship using only a dictionary. There's a deeper level of understanding needed. So, what's their solution? Let's step into our memory palace. Picture a grand library, each room dedicated to a specific aspect of this research. In the first room, we have hypothetical tool generation. The core idea here is to get the LLM to dream up what tools might be useful for a given task. Think of it as brainstorming with your digital self. The paper uses the following method. 1. Provide a question or request to the LLM. 2. Prompt the LLM to generate hypothetical tools it thinks could solve the question. These tools include a thought process, name, and description. 3. Instruct the LLM to generate the same number of tools as the answer requires. For instance, say you ask, I'm planning a BBQ. Should I, the LLM, instead of just looking for weather tools, might imagine tools for checking location details, finding nearby stores, or even creating a custom BBQ playlist. But here's where things get interesting. Simply generating these hypothetical tools isn't enough. The LLM retriever needs to understand the relationship between these dream tools and the real tools available. That leads us to our next room, tool alignment. Now, imagine each hypothetical tool dancing with its real-world counterpart. The goal is to create a clear mapping between the LLM's imagined solutions and the actual tools in its arsenal. The paper uses the following method. 1. Treat hypothetical and gold tools as sets in a bipartite graph. 2. Compute a semantic similarity between the hypothetical tool and gold toolsets. 3. Perform minimal cost matching using the Hungarian algorithm. This is where the ToolDreamer framework shines. It uses a clever algorithm to align these hypothetical tools with the actual tools, creating a training dataset that teaches the retriever to recognize useful connections. Finally, we arrive at the retriever training room. This is where the magic truly happens. The retriever, armed with the aligned tools, learns to fetch the most relevant tools based on the hypothetical ones. The paper uses the following method. 1. Use the assembled training dataset of questions and aligned hypothetical gold tools. 2. Optimize the retriever using info-NCE loss. 3. Teach the retriever to push the hypothetical tool toward its gold tool, while moving it away from negative or irrelevant tools. The ToolDreamer framework optimizes the retriever using info-NCE loss. By teaching the retriever to associate hypothetical tools with real ones, the LLM can more effectively select the right tools, even if the initial query is vague or poorly worded. Now, some of you might be wondering, does this actually work? Well, the authors put ToolDreamer to the test using a dataset called ToolRet, a comprehensive benchmark for tool calling. The results? Impressive. ToolDreamer significantly improved the performance of both sparse and dense retrievers, with gains of up to 19% over existing methods. But wait, there's more. The authors also explored different ways to represent the input to the retriever, finding that including the LLM's thought process behind each hypothetical tool further enhanced performance. It's like giving the retriever a peek inside the LLM's mind. Of course, no research is without its limitations. The success of ToolDreamer hinges on the quality of the hypothetical tools generated by the LLM. Also, the reciprocal rank fusion used in the framework adds another layer of processing which increase evaluation time. But overall, ToolDreamer offers a compelling solution to the challenge of tool retrieval for LLMs. By offloading a portion of the reasoning burden to the retriever, it allows LLMs to handle a larger collection of tools without overwhelming their context windows. So, what does this all mean for the future? Well, imagine a world where AI assistants can seamlessly access and utilize a vast array of tools, adapting to our needs with unparalleled precision. That's the promise of ToolDreamer, a step towards truly intelligent and helpful AI. Fine, yeah, I guess. Look, the point is, this paper is a big deal. It's not just about better tool retrieval, it's about unlocking the full potential of LLMs and creating AI systems that can truly augment human capabilities. Until next time, keep exploring, keep dreaming, and keep pushing the boundaries of what's possible.